this lesson that we're about to do is the next part to the video that you guys all watched last class, right? So what were you responsible for doing last class? You were responsible for factoring, taking out the greatest common factor, using the area model, correct?
Yes.
So today, I'm going to try to transition you from the area model to grouping, right? Which is another way in which we can factor. Now, this is what I want to talk about real quick. I'm pulling you away to do the math, but I'm going to bring you back to real world content, right? But I can't take you there until you know how to do the math, right? So why are we doing this? Why am I even learning how to factor? You are learning how to factor because factoring is one of the methods that we use to find the solutions to a quadratic function. Are y'all with me? Before we did tables, right? We created these tables that helped us to be able to graph the function. Once we created the tables we were able to plot, we were able to find the x-intercepts. Graphing was one way in which we could find our solutions, right? What was another way in which we could find our solution to a quadratic function? Quadratic formula. We did the negative b over 2, negative b plus or minus square root b squared minus 4ac all over 2a, right? Plug in your a, b, and c, and it tells you, it gives you out the actual solutions, right? You can have what? You can have one solution, you can have two solutions, or you can have what? No solutions. And under what circumstance did we have no solutions? If our discriminant was what? Negative. If what was under that radical was negative, that means it's no solution. That means that parabola does not touch the x-axis. Are you guys following me?
Yes.
So what are we doing now, ladies? We are doing another way. We're learning another way to solve quadratic functions. Again, why am I solving quadratic functions? Because I need to find the x-intercepts because x-intercepts are the solutions to quadratic functions. Are y'all with me?
Yes.
We know how to graph to get it. We know how to use the quadratic formula to get it. And now we're learning how to factor to get it. So what you did the other day was you used the area model to help you understand how to pull out the greatest common factor to find your two binomials, right? And I was hoping you guys were able to figure out how to do that using that video, right? So today what we're doing is we're going to move away from the Punnett square and use grouping, which is the same thing as it does the same thing the Punnett square does. Same exact thing, except we're just not setting it up the same way, okay? So follow me as I walk through these with you, okay? And if you got questions, make sure you ask me. Something about this, because I'm recording. Yes?
Is like grouping like combining like terms?
No. Grouping is what you were doing with the Punnett square. Remember when you had the Punnett square, you plugged in what you got, and then you pulled out what they had in common, and then the rest that you left, that was the binomials, that's grouping. Okay? So I'm going to do both of them for the first couple ones, the area model and the grouping, so you guys can see how they're simpler. Okay? All right, so let's go. So let's start with this first problem. Now, what I want to start off by saying is, that when they present these functions to you, they are not going to look like this first one, Leonel. Because this first one that we have, x squared plus 2x plus 5x plus 10, is this simplified? No. How do you know it's not simplified? Because you got like terms. So they're not going to ever give you an unsimplified, not like this, not with 4 terms, right? But why am I giving you 4 terms? Because in a Punnett square, we got 4 boxes. Are y'all with me? So I'm trying to show you the idea of pulling out the greatest common factor using the Punnett square, and then I'm going to transition you so you can see how we can do it without it. Is everybody following?
Yes.
All right. So if we start here, let's just do the area model real quick so you guys can see the connection, okay? So in your notes, let's do an area model real quick. Let's create a Punnett square. And then we're going to plug in the information. What always goes in the very first square? The A, the first one. The first, not the A, but the first term goes in the first box. The last term always goes in the last box. And depending on what you got here, they go in one of these 2 boxes. Are y'all with me? Yes. So this is going to be x squared. What's going to go in my last box? Positive 10. And then since they already gave me 2 terms, I can just put them here. It doesn't matter which one you put where. positive 2x, and positive 5x. Could you have put positive 5x here?
Yes.
Yes, and the 2x here? Yes. It doesn't matter where you put the 2 in the middle. First term, first box. Last term, last box. If you don't have a last term, what would this last box be? 0, and then your 2 middle terms go here. Everybody got it? Notice we're starting with 4 terms. That won't always be the case. We're going to gradually lose terms, okay? You with me, sir? You sure? Okay. All right, so I'm looking at this. How do you get x squared? X times x, right? So I'm just going to put x here and x here because that's how I'm going to get that x squared. All right? Now, what is the greatest? We've already pulled an x out of here. Are y'all with me? Once you got these first two, it's easy to do the rest, right? So, how do you get x squared? It is x times x, right? How do you get, say, 2x?
2 times x.
2 times x. How do you get 5x? 5 times x, right? Now, how do you get 10? 5 times 2 or 10 times 1. But why do I prefer to use 5 times 2? Because I'm looking for a common factor. And since this one already using 5, then I want to use 5 again if I can, right? So this is going to be 5 times 2. So now what am I looking for when I do that? I'm looking for what do they have in common? What is the greatest factor that they have in common that I can pull out? Well, we already pulled out this x here because this one has an x and this one has a what? X. So we're really pulling out an x. Are y'all with me?
Yes.
What do these two, what is the greatest thing that these two have in common? 5. So I'm going to pull this 5 out. What kind of 5 is it?
Positive.
So I'm going to put a positive 5. The only time you pull out a negative is if the leading, what's in the front, is negative. Are y'all following?
Yes.
Yes? All right. Now I'm going this way. Well, I pull the x out and I pull the 5 out. So the only thing left here is a what? That's not a 2, y'all. That's the square.
Oh.
What's the only thing left here? X. So this is going to be an x. Y'all see that?
Yes.
Now, here I pulled out a 5, and here I pulled out an x. What's the only thing these two got in common?
2.
So what kind of 2?
Positive.
Positive 2. So now I pulled out a 2. Are y'all with me?
Yes.
And guess what I just did? I just factored. I just factored this. Are y'all following me?
Yes.
What are my factors? It's going to be x plus 2.
We can't see this.
Oh, sorry, baby. X plus 2 times what? X plus 5. That's it. I just factored this. Then there comes up here. Right here. X plus 2 times x plus 5. Everybody got it?
Yes.
Now, we just used the Punnett square, the area model, to do it, right? Let's go now to this paper. And I want to show you the same idea, but I want to use grouping so you understand it, okay? So first thing we're going to do is we're going to simplify the expression, and then after we simplify the expression, we're going to identify the A, B, and C. So you told me earlier this is not simplified, right?
Yes.
Okay? So then what do I need to do to simplify?
Combine
The like terms. So what is this going to be once I simplify?
X.
X squared plus what?
7x
7x plus 10. Everybody with me?
Yes.
Now let's simplify it. Oh, we simplify. Let's find the A, B, and C. What's my A? 1. What's my B?
7.
And what's my C?
10.
10. Now we're going to use grouping to factor this. So let's group. If I group, watch what I do. I'm going to write x plus 2x plus 5x plus 10. I'm going to write just what they gave us, right? I'm sorry, x squared. Thank you, baby. Right? Now watch. I'm going to group them. What do we use to group? We use parentheses, right? To group things. A group is simple. So I'm going to group this. Y'all with me? I always got to have a plus sign right here. If this is a minus sign, I'm going to put it inside with this and make that a plus. Are y'all with me? You follow what I just said? Let's say this would have been a negative. Right? I'm not going to group that. I need this to be a plus sign, so I will put the negative inside. Are you following me? All right? So, but it's a plus sign, so I don't got to worry about that part. So this is a plus. And this is 5x, so I'm going to group this. You always want a plus sign in the middle. I'm going to show you why in a minute. Yes. Huh? You're going to get it wrong. Okay. So do this. Do what I'm telling you. So watch this. If you don't do that, now you're multiplying these two things instead of adding them. You follow what I'm saying? And we don't. This is all plus, 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 plus. So I don't want to not have a symbol, because now don't that look like multiplication?
Yes.
We don't want that. We want this to be addition. Are you following? Okay. So now watch this. What is the greatest common factor between x squared, which is x times x, and 2x? X. Or 1x, right? X or 1x, correct? So now I'm going to pull that out, and look what I'm doing. I'm going to put a parenthesis. If I take an x out of here, if I divide this by x, what's going to be left? An x. If I take an x out of positive 2x, what's going to be left?
2.
What kind of 2?
Positive 2.
Positive 2. This is the same exact thing we do with the area model, isn't it? Watch. That was x squared plus 2x. On our area model, isn't this x squared plus 2x?
Yes.
And what did we pull out? An x and a what? Positive 2. We took out an x and it left us with x and 2. Y'all see that?
Yes.
That's the same thing we do, except we're not using a box, but it's the same thing. Pulling out the greatest common factor over x, what did it leave us? X plus 2. So I'm here, I group them together. If I pull out a common factor of x, what does it leave me with? X plus 2. Y'all see that? Yes? Now I'm looking at 5x plus 10. 5x is 5 times x. 10 is 5 times 2. What is the greatest common factor between 5x and 10? 5. What kind of 5? So I'm going to pull out a positive 5. All I'm doing is what was done here. What is the greatest common factor between 5x and 10? 5. So I pulled out a 5. Y'all see that? Now, once I pull out a 5, if I take a 5 out of 5x, what's left? X. I'm really just dividing, right? If I divide 10 by 5, what's left? 2. What kind of 2? Positive 2. Same thing. Watch this. What happened? Pretend this part is not here, right? I pulled out a 5. Y'all see that? Put a 5 out of these two. What was left? An x out of this one, and what? A positive 2 out of this one. Do you see that? It's the same exact thing we've been doing. But here's what I want you to see. What do you notice about this and this? They're the same thing. Same thing. What was left was the same thing. When you pull the x out of the first one and you pull the 5 out of the second one, it left you with x plus 2 for both of them. Are y'all with me? Now, here's where the magic happens. X times x plus 2 plus 5 times x plus 2 is the same thing as saying x plus 5 times x plus 2. Isn't it? Aren't we multiplying the x by x plus 2? Wouldn't we do that here? If we distribute it? Aren't we multiplying the 5 by x plus 2?
Yes.
Wouldn't we do that here if we distribute it?
Yes.
So instead of writing it like this, I just rewrite it like this. And now I just did what we did with the Punnett square. We just factored this. We did the exact same thing we did with the Punnett square, except we didn't put it in a box. Right? Now, can't we check this to make sure that our answer is still correct? Yes, so we go here, we got x plus 5 times x plus 2. What am I looking for this to do? I'm looking for it to give me this x squared plus 7x plus 10. Y'all see that? Yes? So let's go. What's x times x?
X squared.
X squared. What's x times 2?
2x.
2x. What's 5 times x?
5x.
5x. What's 5 times 2?
10.
Positive 10. Combine like terms. X squared plus 7x plus 10. Done. So what am I doing? I'm checking to make sure I factored it correctly. Did I factor it correctly?
Yes.
Yes. Now I want to ask you something real quick. What if this would have had in the front a y equals, right? Then this would have been y equal. What form is this function now in? Factored form. We went from standard form to what? Factored form. And can you tell me my solutions? What will my solutions be here? They will not be 5 and 2. Negative 5 and what? Negative 2. Those will be my x-intercepts. Are y'all following?
Yes.
So why is it important to know how to rewrite this rule in factored form? Because if you give it to me in standard and I can rewrite it in factored, then I can find my solutions real quick. Are y'all with me?
Yes.
And one of our ways we can do that, other than graphing, right? Other than quadratic formula, is by factoring. That did not take as much time as doing a quadratic formula. Are y'all with me? And the more you do it, the easier it'll become to you. Now I want you to see something. Watch this. We got a 5 and we got a 2. What do you get when you add 5 and 2? 7. Isn't that what's right here?
Yes.
What do you get when you multiply 5 and 2?
10.
Isn't that what's right here?
Yes.
Oh. There's a connection there. All right, let's go. Let's do the next one. All right. Next one. X squared plus 7x minus 7x minus 70. First thing I want to do is simplify this thing because it's not simplified. What terms am I going to combine?
10x and 7x.
10x and negative 7x. What am I going to get?
3x.
3x. So tell me what to write. X squared
plus 3x
plus 3x
minus 70.
minus 70. So now can we identify our A, B, and C?
Yes.
Yes. What's our A?
1.
1. What's our B?
3.
3. What's our C?
Negative 70.
Negative 70. All right. Now let's use this grouping. What am I writing? I'm writing x squared plus 10x then what am I going to put here? Plus. And then what am I putting here? Negative 7x and what? Minus 70. Does everybody see what I just did?
Yes.
Yes. What am I doing? I am grouping my terms, putting them together. Why am I doing that? Because I want to pull out the greatest common factor. Are y'all following?
Yes.
What is the greatest common factor between x squared and 10x? X. Once you pull out an x out of x squared, what do you have left? X. When you pull an x or divide an x out of 10x, what do you have?
10.
Positive 10. Now watch this. This is a hint for me. I don't know what he said. He talking to me? This is a hint, because what does this tell me? What happened here? Wasn't these the same thing? So if I did this right, what do I expect to see over here? The same thing. So that kind of helps me to know what to pull out, right? If I want this next one to be a positive x, then what do I need to pull out of here if I want this to be x? A negative 7, right? Because you want that x to be positive. Are y'all with me? So it's giving me a hint of what to pull out. Are y'all following me? All right, so I'm going to go over here now. And I'm going to put right here, I'm just going to put it here because I know that's what I want it to be. I want it to be x plus 10. I know that's what I want. So how do I get this to be an x plus 10? I got to pull what out of here? Negative 7. Why? Because negative 7 times x is negative 7x. And negative 7 times 10 is negative 7. Oh, I'm good. Once you get that first one, the rest of it should be easy. Are y'all following?
Yes.
Now, because these two are already the same, how can I rewrite this so that I have two binomials? X plus 10, okay, times what? What is being multiplied by x plus 10? Not just the negative 7, but also the what? The x. So wouldn't this be x minus 7? You put these two together because these two are going together. Does that make sense? X times x plus 10 minus 7 times x plus 10 is the same thing as x plus 10 times x minus 7. And now I have factored my function. What is the solution to this function? Negative 10 and what?
Positive 7.
And positive 7. Those are going to be the solutions. Ask me a question. Maybe you just need to see a little bit more. Yeah? All right. Can we check it?
Yes.
Yes. X plus 10, x minus 7.
X squared.
How do we check it? Distributive. X times x?
X squared.
X squared. X times negative 7. Class,
Negative 7x.
thank you. 10 times x. Positive 10x. 10 times negative 7. Negative 70. And if we combine like terms, x squared, you got a positive 10 and a negative 7, that's 10 minus 7. 3x minus 70. Y'all follow? Now watch this. So we know we did that correct, right? Because we got what we started with. Now watch this. What is 10 take away 7? 3. Isn't that a 3? What is 10 times negative 7?
Negative 7.
Isn't that my C?
Yes.
You starting to see a pattern?
Yes.
All right, let's do it again. Can we simplify this? What would it be?
X squared.
X squared. What we got? Plus 9. So we drop in the middle terms. Do they cancel? Or do they become negative 6?
Negative 6.
What kind of 3 is this?
Negative 6x.
What kind of 3 is this? Now, if one would have been negative and one would have been positive, then we could drop it. That means we got no B. Then we just would write that 9, right? But in this case, it's going to be x squared minus 6x plus 9. Everybody see that?
Yes.
Yes? So we got A equals, B equals, C equals. Shlini, ask me a question. You good? Okay. What's my A?
1.
1. What's my B?
Negative 6.
Negative 6. What's my C?
9.
9. We ready?
Yes.
All right, let's go. What am I writing in my first parenthesis?
X squared.
X squared plus?
Minus 6.
No, we need 4 terms to group. We didn't have 3 terms, y'all. We got 4 terms, right? So x squared what? Minus 3x. Y'all with me? Yes? And then I'm going to put a plus sign here, right? And then what's going to go in here? Negative 3x plus 9. Now remember, when do we pull out a negative? If there's a negative in the front, right? So let's go. What is my greatest common factor here? X. If I pull an X out, tell me what is left. X minus 3. Everybody agree?
Yes.
Yes? You good, Jeffrey? All right, now here, what do I have in the front? A negative. So guess what I'm going to pull out? I'm going to put negative right here. What am I pulling out? If I'm going from negative 3x and I know I want just an x inside my parenthesis, what am I pulling out? Am I pulling out a 9 here?
3.
No, 3.
I'm pulling out a what? A 3. Why? Because what do I want left in here? X minus what? 3. Right? Let's check. Negative 3 times x, does that give you negative 3x? Yes. Negative 3 times negative 3, will that give you a positive 9? Yes. So that means we pulled out the correct term. Are y'all with me? Yes? All right, so we already know one of our parentheses is going to be what? X minus 3. And then now we put these two together, right? Which means it's going to be what? X minus 3. What is negative 3 plus negative 3? Negative 6. Isn't that what we got right here? What's negative 3 times negative 3?
9.
Positive 9. Do you see that? Notice that to get a 6 that's negative, both of these had to be negative. Y'all see that? There will be one solution. Absolutely. And what would be, what would be our one solution? What would be our one solution, people? Positive 3. Absolutely. Are we all good here? Yes? All right. So check it. I'm going to do it real quick. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. These two are like terms. So x squared minus 6x plus 9. Did it correctly. Everybody good there?
Yes.
Yes, great. We got 9 minutes. I ain't gonna finish this. But that's okay. Are we all good here so far? Yes. All right, let's go here. X squared minus 4x plus 4x minus 16. Uh-oh. That should send off some signs, some bells. They're going to cancel. Why are they going to cancel?
Because it's negative 4.
Because you got negative 4x and a what? Positive 4x. So help me rewrite this. X squared minus 16. That's it. That's it. X squared minus 16. Now watch this. It could also be x squared plus what? 0x minus 16. Right? Where is this parabola's vertex going to sit?
On the y-axis.
On the y-axis. How do we know that?
Because there has no shift.
There is no shift. The B is gone. There is no shift. Are y'all with me? So the vertex is going to sit on the y-axis, which means it's also going to be the y-intercept. Now, let's just play with this for a minute. Give me, okay, let's do this. What's my A?
1.
1. What's my B?
0.
0. What's my C?
Negative 16.
Negative 16. Question. Is it negative 16?
Yes.
Yes, it's negative 16. Here's my question. Give me two numbers that when you add them, they give you 0. But when you multiply them, they give you negative 16. When you add them, they give you 0. And those same two numbers, when you multiply them, they give you negative 16. What is it? Negative 4 and what? Positive 4. Isn't that what was here in the middle? Negative 4 and what? Positive 4. Watch this. Let's keep going. What do we have here? X squared minus 4x plus 4x minus 16. Y'all with me?
Yes.
Common factor. Greatest common factor here. X. Pull out an X. What do I have left? X. Come on. We should know more by now. X what? Minus 4. I hear the same three people. What is this? X minus 4 going to be left, right?
Yes.
Does everybody understand how I'm getting this X minus 4? Because y'all kind of silent on me. Yes? Because if you work backwards, X times X, wouldn't they give you X squared?
Yes.
And wouldn't X times negative 4 give you negative 4X? Yes? For those that's still not getting it but not talking to me because you're scared to say something. Watch this. X times X, negative 4 times X. What do they have in common? The X, right? So this is what I can pull out, is the X. I pull an X out of both of them. That's why it's out front. What is left once I pull out that X? An X and a what? Minus 4. That's where we're getting that from. Are y'all following?
Yes.
Yes? Same thing here. How do you get 4x? 4 times x. How do you get negative 16? 4 times negative 4. Does everybody see that? What is the common factor between these two?
4.
A positive 4. Why am I not pulling out a negative right now? Because the negative is now out front. Are y'all with me? Keely, you with me? Yes? So I pull out this 4, what's going to be left? If I pull out this 4 and this 4, what is going to be left? X minus 4. And don't these two look alike? Yes, so we're going to put them together. X minus 4. And then once we put these two together, what do we have left?
X plus 4.
X plus 4. Y'all see that? This and this are left once you pull that out. Does that make sense?
Yes.
So what's going to go here? X plus 4. And boom, what did you tell me were the two numbers? Look, 4 and what? Negative 4. So how about this? When you said that, I could have just did this. X plus 4, X minus 4. Without going through all this, I could have just done that. Because you were able to see what the two numbers were. Do you follow me?
Yes.
This is where we're going. To the point where I don't have to do this part anymore, Jeremiah. I'm trying to get to the point where I don't have to do this anymore. And all I can do is once I guess these numbers, I can just put them right here. Yes.
Do you have to flip them? Like you see how you had the negative 4 and then the plus 4, and then you had at the bottom you had plus 4 and then negative 4?
Is A times B the same thing as B times A?
Oh, yes.
Yes. So do they have to be in that order? Very good. Everybody understand this? Yes? All right, let's do this last part. All right, so let's go. We have x
minus-
plus 4. Either way.
Okay.
X minus 4. So then, let's distribute. X times x,
X squared.
x squared. X times negative 4, negative 4x. 4 times x,
Positive 4x.
4 times negative 4.
Negative 16.
So now we got x squared. These two become what? 0x minus 16. And you can drop that. So x squared minus 16. And here's something else I want you to see. Anytime you're missing a b in the middle, that means something had to cancel out. And what's the only way they could cancel out? They got to be what? Opposites. Positive and a what? Negative. So every time they ask you to factor something like this, and you see the b is gone, then that means it was a positive and a negative of some number. Are y'all with me?
Yes.
Yes? Is everybody good on this?
Yes.
Are there any questions? Okay, so I want to do number 5, and then next time we come to class, we're going to finish it up. All right, so number 5 on the back. We still got 3 minutes. Y'all know I teach bell to bell. So let's go. It says, see the table at the right. So let's look at this table. I want you to help me find the D and the E. I want everybody real quick, take a minute. Look at this table. It's a Punnett square. They've already pulled out the X. Help me find the D and the E real quick. What do you think should be pulled out of both of those? What would they have in common?
No.
The D would be what?
Negative 3.
Negative 3.
And the E7.
And the E would be what? Positive or negative?
Positive.
Why positive?
Because
Because the one in the front is what? Positive. But also because what times negative 3 is going to give me a negative 21?
positive 7.
Got to be a positive what? 7. So our numbers are positive 7 and what? Negative 3. Can I write these as 2 factors? What? X minus 3 and what? X plus 7. Are y'all following? All right, we'll pick up here next class.